Class, welcome back to another video on Chapter 4, or from Chapter 4. Today we are going over a new theorem that will allow us to solve for congruent triangles. Alright, and we call it the hypotenuse-leg theorem. For short, we can use HL, but actually guys, you know what? What I'm going to do, I'm going to cross this off. I want to see RHL. And I will show you why in a second, okay? So here we go. If the hypotenuse and a leg of a right triangle are congruent to the hypotenuse and a leg of another right triangle, well then the triangles are congruent. Alright, so this is why I'm going RHL, because I want you to understand that you need a right triangle, you need the hypotenuse, and you need the leg of one triangle, and then you need another triangle to be a right triangle, and then you need the hypotenuse and the leg again. Okay, so RHL, RHL, RHL. Now, real quick, I don't know if you guys remember, but hopefully we do. When you guys have right triangles, it's really important to understand what I mean by hypotenuse and leg, okay? Across from the right angle is always the hypotenuse. And the two shorter sides, so 1 and 2, these are called legs. Oh, can't see that. All right, those are my legs. Right here and right here are the legs. The hypotenuse is always the side across from the right angle. Okay? So we look at this picture. The first thing I look at, and I see that I have two right triangles. Okay, so my R is good. R is good because of my right angles B and E. Let's see, H, hypotenuses. I need the hypotenuses to be congruent. Well, I see double tick mark on both hypotenuses, so that's good. And lastly, I have a leg and a leg congruent, so we are good there. We know that these triangles are going to be congruent through RHL. Now we just have to line everything up. Now once again, this turns into a matter of preference. I'm going to go ABC. Alright, I'm going to say ABC. And I know that's going to be congruent to triangle. Well, I need to match everything up. Please note, A is here. It is not touching either of my two tick marks, right? My single tick mark and my double tick mark are both touching C. So I'm going to look, and I'm going to see that A actually corresponds with D. And then B, the right angle, corresponds with the right angle E. And then C, my last vertex, lines up with F, just like that. And again, why is this? Well, it's because of RHL. Alright? So let's take a look at some of these, because these are important. You have to understand now, we have a couple of different things that might be going on. And this first example down here at the bottom is perfect. Or not, yeah, it's perfect. It's going to help us out quite a bit understanding what we're looking at, okay? So when I look at this triangle right here, this kind of top triangle, I'm looking at a right angle, but do you notice that I don't have a hypotenuse? I have both legs. If I have both legs, then this is actually trying to use side, angle, side, because this right angle is between the two sides. Now this one over here, now I see my right triangle, hypotenuse and leg. So what I want you to understand though, well, this one is trying to use RHL, this one's trying to use side angle side. This is a none because we don't have corresponding parts that are congruent, okay? Things are not lined up correctly. Now when we look at number 2, you need to remember that not just because we have right angles doesn't mean we're always going to try to use this RHL. We can still say that right angles are congruent, right? So I have two sets of angles, and then the side is included, so this is ASA. Alright, number 3. We take a look. I make my mark to show that I have a shared side. Normally, when we would look at these right angles, we would say, okay, well I have one set of angles that are congruent, and then I have a set of sides and another set of sides, but this would be Ooh, the angle's not included. So this would be SSA, or what do we think? ASS. Can't have it, right? So what I need you to understand, and I need you to just kind of like take away from this video, is that now we have a very specific situation where SSA works, okay? And we don't call it SSA. We say that we have right triangles, right? Because we have right angles, so right triangles. And then we have a hypotenuse that are congruent and legs that are congruent. So this is RHL. On to the last one. If we take a look, we know that we have sides, angles. Oh, we also have vertical angles. So if this is a right angle, I could also say that that's a right angle. And if we look, we have two sets of angles, one set of sides. The side is not included. It's not between my two angles, right? They're on the outside. So this would be AS. All right? So let's jump into a couple of practice proofs to show you how RHL works. Something like number 5. All right, number 5. First and foremost, nothing changes, right? We still do the same procedures. We're still going to look at the pictures, try to mark anything that we can. So PQ is perpendicular to QR means I can put a right angle symbol there. PS perpendicular to SR means I can put a right angle symbol there. I can also say, ooh, QR is congruent to SR. And then, of course, what do we see right in the middle? That shared side. All right, so when we look at this picture, we have to kind of think about it in two ways, right? If I was trying to think angles and sides, I would have angle, side, side, and we know that that's not okay. But, what did we just learn on the page before? We have a very specific angle, side, side situation that works, and we don't call it that. We say that we have right triangles, because of the right angles, and then we have a hypotenuse that's congruent to the other hypotenuse, and the two legs that are congruent. So I know I'm going to be using RHL. All right? So here we go. We're still going to write our givens out. So PQ perpendicular to QR, and PS perpendicular to SR, because given, and 2, QR is congruent to SR, because given. Now, if we look at QR and SR, are those the hypotenuse, hypoteni of the two triangles, or are those the legs? Those are the legs, right? They are not across from the right angle. So I would put an L right here so I know that my L from RHL is done. All right. Now, we need to get an R. We need to get an H. I would say the H is going to be easiest, so I'm going to do that one next. Where's the H? Oh, it's right there. Okay. PR is congruent to PR, and we know why. Reflexive. Reflexive property. Okay. That is my hypotenuse. So now I have my H done. So now I know my L is done, my H is done. I just need to get right triangles. Be very careful. What did I say? I said we need right triangles. And again, I'm going to show you. It's very important that you understand you need right triangle. Right triangle. Not right angles, right triangles. Okay. Now hopefully me pointing that out made you understand, and you can kind of think what we're going to need here, because I very easily can say now that angle Q and angle S are right angles. Why can I say that? Well, because I know perpendicular, and I know that if perpendicular, then right angles. Okay? If perpendicular, then right angles. Am I ready? Can I put an R here? No, I cannot. Okay? You need to be very careful. What was I just saying? I don't want right angles. I want right triangles. Okay? So I'm great. I'm happy that I know now that Q and S are right angles, but I need to go one step further. And I need to say triangle PQR and triangle PSR are right triangles. And how do I know that? If right angle, then right triangle. Okay, and I know that seems kind of silly, but it's very important that you know the difference. I don't just need right angles, I need right triangles, because that's what the theorem says. So now that I have right triangles, I can say I have my R, and now we know we're ready to finish up the proof. I can now say triangle QPR is congruent to triangle SPR, and I used the RHL postulate or theorem. RHL means I went 5, 3, 2. 5, 3, 2. R5, H3, L2. Okay? Perfect. Beautiful. Nicely done. Let's do one more together, and then we'll practice more in class. Alright, so as we come down here, we take a look. Okay, I have some more perpendicular lines, so let's mark it. RS and SV, UT and TV. RS is congruent to UT, so boom, boom. I see that V is the midpoint of RU. Alright. Now this one is actually a good example of where you could use multiple different methods to solve this one, or to prove this one, because we could use vertical angles. I'm going to draw them in just so you know that they're there. But I want you guys to understand, like, you only need to use the 3 pieces. Okay, you prove it however you want. Now, I'm going to choose to ignore these vertical angles for right now, so I'm not going to mention those in my proof. I'm going to continue, because this chapter, or this video, is on RHL. I'm going to use the fact that I have right angles, so I have right triangles, and I have congruent hypotenusae, and I have congruent legs. So once again, I'm going to say that I'm going to use RHL. Okay? Could you have used angle side? Sure. Yes, absolutely. But again, for this video, because we're doing RHL, let's use RHL. So we write our givens. Let's see. RS perpendicular to SV, UT perpendicular to TV, given. RS congruent to UT, given. V is midpoint of RU, given. Alright, let's take a look. What do we have already? RS congruent to UT, RS congruent to UT. Oh, those are my legs. Okay, so I already have my L done. My leg has been taken care of. I still need to get the H, I still need to get the R. Let's go ahead and get H again, just because I think that might be easiest. Where are my hypotenuses, or hypotenusae? Oh, well, those are RV and UV. So let's say that RV is congruent to UV, and we have to decide, well, how did we know that? Well, we knew this statement was true because V was the midpoint, so that is going to be the reason. If midpoint, then divides segment into 2 congruent segments. Okay? Sweet. Now I have my hypotenusae congruent to each other, so I have my H. Now again, I just need those R's. Okay, the R, again, the R stands not for right angle, it stands for right triangles. Not right angles, right triangles. So, you have to do 2 steps here. Remember, from perpendicular sides, or perpendicular lines, we can get right angles. So let's get those angles. We can say angle S and angle T are right angles. And we know because if perpendicular, then right angles. But you have to remember, I don't want right angles, I want right triangles. So we now need to say triangle RSV and triangle UTV are right triangles. And how do we know that? Because if right angles, then right triangles. I know you guys might seem or think that this is silly and stupid. I just want you guys to remember logically, like, things have to go in order, right? There has to be a progression. And this isn't even just math. I mean, in general, when you're trying to come up with a solution to a problem, like, there needs to be procedures, like, right? You want to try and figure things out and understand the pathing to get to the correct solution, okay? So now that I have right triangles, I can put my R there, and now because I have RHL all done, I can go right to my prove. RSV is congruent to UTV, and we know because of RHL. We used line 6 for R, we used line 4 for H, and we used line 2 for L. So there you have it. There are some RHL postulate or theorem proofs. I hope these don't seem too bad. Please, please, please make sure to understand this. If you have to rewatch the video, do it, okay? But I hope this stuff is making sense. Semester's coming towards an end. We need to make sure that we are doing okay and that we're ready for our test. All right? Have a good one.